A certain football quarterback can throw a football a maximum range of 80 meters on level ground. What is the highest point reached by the football if thrown this maximum range? Ignore air friction. Solution. Here we can use two formulas. One is for range and other for height. For range we have this formula. If a ball was thrown under angle theta with a speed v, so the total range d will be like this, and the total height will be like this. Now we can divide height by range, and we will get this formula. And now we can use this formula to solve this problem, because for maximum range we have angle equal 45 degrees, and the tangent 45 degrees it's 1. So it means that height 4 times less than range, and the solution is 20 meters. Problem number 20. Consider a completely inelastic collision between two lumps of space glue. Lump 1 has mass m and originally moves directly north with the speed v0. Lump 2 has mass 3m and originally moves directly east with the speed v0 over 2. What is the final speed of the masses after the collision? Ignore gravity and assume the two lumps stick together after the collision. Solution. Here we can use momentum conservation, and let's just count what is initial momentum and equalize it to final momentum. Initial momentum. In the x direction we have this expression. We have mass 3m multiplied by v0 over 2. That's momentum in x direction. Momentum in y direction. That's mass m multiplied by v0. And now we can count what is total momentum of system, which is just a square root from squares of both momentums, which is this expression. And now to count what is total speed, we just need to divide this momentum by total mass of these two pieces which moving together. And that's the result. As we can see, correct answer is C. Problems 21 and 22. The following information is used for questions 21 and 22. Two stars orbit their common center of mass as shown in the diagram below. The masses of the two stars are 3m and m. The distance between the stars is d. Question number 21. What is the value of the gravitational potential energy of the two-star system? And question number 22. Determine the period of orbit for the star of mass 3m. Solution. Gravitational potential energy of two objects equal this expression. That's a negative g multiplied by m1 multiplied by m2 and divided by distance between objects. In our case that will be negative 3g multiplied by m squared over d. Question number 22. Determine the period of orbit for the star of mass 3m. Solution. Force of gravity between these two objects equal this expression. 3g multiplied by m squared over d squared. But from other hand, mass 3m rotating around a common center of mass, which is on a distance 1/4 d from this big mass, and it's equal to total mass multiplied by v square over radius, and the radius is 1/4, so that will be 12m v square over d. And from here we can find what is speed of this big mass. That's this one, 1/2 square root from gm over d. And now to find what is period, we just need to use this formula. Period equal to pr over v, where r is radius of orbit. In our case it's 1/4 d, and v is already counted. So finally we have this result, which is correct answer A.